Hello all, welcome to the new lecture of exact equations and integrating factors of the section 2.6 of differential equations. In this section, we mainly discuss about the integrating factors of the differential equation to make an equation exact. So in the last lecture, we have already found that there may be some equations of the form m of xy dx plus n of xy dy equal to 0, or m of xy plus n of xy into dy by dx equal to 0, which are not exact. That means some equations of this form may not be exact. We have discussed one problem of this type in the last lecture, in the previous lecture. Equations of this form are not exact, but we can make these equations into exact by multiplying this equation by a suitable non-zero function, but can be made to exact by multiplying this equation 1 by a suitable non-zero function mu of xy. These functions are called integrating factors. This function mu of xy is called integrating factors. As you know, we have already discussed the method of multiplying this equation with the integrating factors for solving the linear equations, linear first order differential equations. So in the same way, here also, here the functions m and n are functions of x and y. In order to make this equation exact, we can multiply this equation 1 by a suitable function mu of xy. Uh, then the equation will become exact, and then the resulting equation is exact, and we know how to solve an exact equation. So by definition, we know that equation is exact. An equation of the form 1. By a theorem, we have already formed the result that equation of 1 is equation of the form 1 is exact if and only if dou m by dou x, sorry, dou m by dou y equal to dou n by dou x, or we can write in short form as m suffix y, my is equal to nx. So if one is not exact means these two partial derivatives are not equal. If equation 1 is not exact, then we know my not equal to nx by the theorem or by the definition of the exact equations. Then we will make this equation into exact by multiplying this by a suitable function mu of xy. Now our aim is how to find this function mu of xy. So let's discuss the method of finding this function integrating factor mu of xy. Okay, method of finding mu of xy. Okay. So we know that when we multiply this function with the equation number 1, then the resulting equation will be exact. So equation 1 into mu of xy, such a function we have to find. Equation 1 into mu of xy implies what we will get, m mu of xy into m of xy plus mu of xy into into dx is there plus mu of xy into n of xy dy equal to 0, and we know this equation must be will be exact because we have chosen such a function mu. This equation is exact. So by the definition of exactness, we can write it as dou m by dou y. Now here what is the function? Instead of m, here we have to calculate the function a cap m as m dash, or m dash is mu m, and this function we can call it as n dash. Let this whole function be m dash and this be n dash. Now we know since this is this is exact, we can write it as dou m dash by dou y is equal to dou n dash by dou x, or what is dou m dash by, or dou m dash by dou y means m dash y equal to n dash x. Now what is m dash? M dash is mu m. So we have mu m, derivative of partial derivative of y with respect to y is equal to mu n, its partial derivative with respect to x, isn't it? So we can say this must be equal, or we can expanding this we will obtain m into mu is also a function of y, so m into mu y, then here also what will be there, m into nx will be there, nx, so we are taking that mu into m into mu y minus n into mu y is equal to or we can write it as mu into my, then minus mu into nx, so mu into nx. From the right side there is nx, or we can expand by product rule of differentiation, it is mu y into m plus my into mu is equal to mu into nx plus mu x into n. So taking the mu x, these terms mu into nx and mu x into n into the left, we will obtain m into mu y minus n into n into mu x will be there, n into mu x plus mu into my. Mu into my is here, minus mu into nx will be there. So my minus nx is equal to 0, which is a PDE. Okay, let this be equation number 2. So we know that mu must satisfy the, that is mu must satisfy this PDE. So we have to find a mu function mu such that equation number 1 should be exact. Mu into that equation number 1 must be exact. From that means we solving equation 2. So mu can be obtained from solving equation number 2, which is a PDE. So if such a function mu exists, so from 2 solving 2, if such a function mu exists, then equation 1 is exact. So equation 1 will be exact. Equation 1 is exact. Not equation 1, the equation which obtained, then the transformed equation. Then the transformed equation must be exact. Equation is exact, and we can solve by the method of solving exact equations, and can be solved, isn't it? By the method of solving the exact equations. But an equation 2 of the form 2 may have more than one solution. And it is also possible that equation 2 may have more than one solution. there may be more functions satisfying this condition. So equation 2 have more than one solution. In that case, we will take one as a, we can use any one of them as mu. So we can use any one of them as mu. Okay. ഏതെങ്കിലും ഒന്ന് മ്യൂ ആയിട്ട് എടുത്തിട്ട് സോൾവ് ചെയ്യാവുന്നതേ ഉള്ളൂ ആൻഡ് സോൾവ് ദ സ്പെഷ്യൽ now we can discuss about some special cases. So before moving to this, what we have already discussed is some functions may be in the form of the standard form of the exact equation, but when we consider my and nx, when we calculate my and nx, they may not be equal. But if we make some alterations or some, if we multiply the given equation 1 by a suitable function mu of xy as a function of x and y, then we can make it the equation that multiplying this, then we will get another equation, and the transformed equation will be exact. So in that case, we can solve by again by the method of exact equations. So if the given equation is not in the exact form but can be made into exact by multiplying it by a by a function mu of x and y, mu of xy, such a function is called a integrating factor. നമ്മൾ ഫസ്റ്റ് ഓർഡർ ഇക്വേഷൻസിന്റെ ലീനിയർ ഫസ്റ്റ് ഓർഡർ ഇക്വേഷൻസ് സോൾവ് ചെയ്യുമ്പോഴും നമ്മൾ ഇതേ മെത്തേഡ് തന്നെയാണ് പറഞ്ഞിട്ടുള്ളത്. അതിനെ അവിടെ നമ്മൾ മൾട്ടിപ്ലൈ ചെയ്യുന്ന ഫംഗ്ഷൻ ഇന്റഗ്രബിൾ ആക്കാൻ വേണ്ടിയിട്ട് മൾട്ടിപ്ലൈ ചെയ്യുന്ന ഫംഗ്ഷൻ എന്താണോ അതാണ് ഫംഗ്ഷൻ ഓഫ് അതാണ് ഇന്റഗ്രേറ്റിംഗ് ഫാക്ടർ എന്നുള്ളത്. അവിടെ നമ്മൾ എന്ത് ചെയ്യുന്നുള്ളൂ, ആ ലീനിയർ ഫോമിൽ എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ ആ ഇക്വേഷന് അതിലത്തെ ഇൻഡിപെൻഡന്റ് വേരിയബിൾ എക്സ് ആണെങ്കിൽ ഇപ്പൊ മ്യൂ ഓഫ് എക്സ് ആ രീതിയിലായിരുന്നു അവിടെ ഇക്വേഷൻ ഉണ്ടായിരുന്നത്. പക്ഷെ ഇവിടെ ഈ ഒരു രീതിയിൽ എന്താണ്, മ്യൂ എന്നുള്ളത് ഈസ് എ ഫംഗ്ഷൻ ഓഫ് എക്സ് ആൻഡ് വൈ ആണ്. Okay, it can be a function of x, can be a function of y, that also possible, but mu is a function of xy, x comma y. Okay, so അങ്ങനെ ഒരു ഫംഗ്ഷൻ നമുക്ക് കാൽക്കുലേറ്റ് ചെയ്യാൻ പറ്റുന്നുണ്ടെങ്കിൽ then equation, ആ ട്രാൻസ്ഫോംഡ് ഇക്വേഷൻ എന്നുള്ളത് എക്സാക്ട് ആയിരിക്കും. സോ വി ക്യാൻ സോൾവ് ബൈ ദ മെത്തേഡ് ഓഫ് സോൾവിങ് ദി എക്സാക്ട് ഇക്വേഷൻസ്. ഓക്കെ, സോ അത് നമ്മൾ കാൽക്കുലേറ്റ് ചെയ്യാൻ വേണ്ടിയിട്ട് നമ്മൾ എന്ത് ചെയ്തു, പുതിയ ഇക്വേഷന്റെ എക്സാക്ട്നെസ് കണ്ടീഷൻ അപ്ലൈ ചെയ്തു. അപ്പോൾ ആ ഇക്വേഷൻ എന്ത് വേണ്ടി, മ്യൂ എന്നുള്ളത് ഒരു ഇന്റഗ്രേറ്റിംഗ് ഫാക്ടർ ആവണമെന്നുണ്ടെങ്കിൽ മ്യൂ മസ്റ്റ് സാറ്റിസ്ഫൈ ഇക്വേഷൻ നമ്പർ 2. സോ ബൈ ഫൈൻഡിങ് ദ സൊല്യൂഷൻ ഓഫ് ദിസ് ഇക്വേഷൻ നമ്പർ 2, we can, if such a function exists, then the given equation can be made to exact. And sometimes this equation may have more than one solution. In that case, any one of them we can choose it as an integrating factor. ഓക്കെ, ബട്ട് ഈ ഒരു രീതിയിൽ നമുക്ക് ഇന്റഗ്രേറ്റിംഗ് ഫാക്ടേഴ്സ് കണ്ടുപിടിക്കുക എന്നുള്ളത് സംടൈംസ് ഇറ്റ് മെ നോട്ട് ബി പോസിബിൾ, ഓർ എന്താ പറയുക, എല്ലാ കേസിലും ഇങ്ങനെ ഈ രീതിയിൽ ഇക്വേഷൻസ് കാൽക്കുലേറ്റ് ചെയ്യുമ്പോൾ ഇറ്റ് മേ ബി ടൈം കൺസ്യൂമിങ്. സോ വി ക്യാൻ ഗോ ടു സം സ്പെഷ്യൽ കേസസ്. ഓക്കെ, അപ്പൊ സപ്പോസ് നമുക്ക് കിട്ടുന്ന ഈ ഒരു ഫംഗ്ഷൻ എന്നുള്ളത് എന്താണ്, ഫംഗ്ഷൻ ഓഫ് എക്സ് എലോൺ മാത്രമാണെങ്കിൽ, സോ ഇഫ് mu of xy, in general it is a function of x and y. So if mu of xy is a function of x alone, x മാത്രമാണെങ്കിൽ then നമ്മൾ ഓൾറെഡി എന്ത് പറഞ്ഞു, mu m with respect to of the derivative with respect to y is same as, we know, mu n of x. Now if mu is a function of x only, അല്ലെ, mu എന്നുള്ളത് mu of x മാത്രം ആവുകയാണെങ്കിൽ ഈ കേസിൽ ഇതിനെ y-യിലുള്ള ഡിഫറൻഷിയബിൾ ചെയ്താൽ എന്താണ്, സോ ദിസ് ഇംപ്ലൈസ് മ്യൂവിന്റെ ഡെറിവേറ്റീവ് ഡോ എം ബൈ ഡോ വൈ എന്തായിരിക്കും, 0 ആയിരിക്കും. അല്ലെങ്കിൽ ഡി എം ബൈ ഡി വൈ എന്നുള്ളത് എന്താണ്, 0 ആണ് അല്ലെ. ഡി മ്യൂ ബൈ ഡി എക്സ് മാത്രമേ എക്സിസ്റ്റ് ചെയ്യുള്ളൂ, നോൺ സീറോ ആയിട്ട് ഉണ്ടാവുള്ളൂ, നോൺ സീറോ ഫംഗ്ഷൻ ആണെങ്കിൽ. ഓക്കെ, സോ നോൺ സീറോ ഫംഗ്ഷൻ ആണ് നമുക്ക് കാൽക്കുലേറ്റ് ചെയ്യേണ്ടത്. സോ ഡി മ്യൂ ബൈ ഡി എക്സ് മാത്രമേ ഇവിടെ എക്സിസ്റ്റ് ചെയ്യുള്ളൂ. അപ്പൊ ഇവിടെ തന്നെ നമ്മൾ ഈ പ്രൊഡക്റ്റ് rule apply ചെയ്യേണ്ട കാര്യമില്ല. We can consider mu as a constant. So mu m of y, അതായത് ഡോ ബൈ ഡോ y ഓഫ് mu m എന്നുള്ളത് mu into m y എന്ന് മാത്രമായിട്ട് മാറും. Okay, so this equation number we don't know, we didn't give any number. So equation number star um, implies mu into my is equal to mu into nx plus n into mu x. Okay, or we can take mu x on only mu x here and taking all other things into the left. So mu x is equal to mu into my minus mu into nx, that is mu into my minus nx. Okay, divided by n will be there, isn't it? So mu x is equal to, and one more thing, what is we need to notice that mu x, mu here, now mu is a function of x alone. So no need of writing the partial derivative. We can write it as d mu by dx. So d mu by dx we obtain it as mu into my minus nx divided by n. Okay, so we have reduced the partial differential equation into this form. Okay, now suppose this mu is a function of x alone, that we know, and suppose uh, this equation, that means mu into this function my minus nx by n. Now this is a PDE, and we can solve this by again by what? And solving this we will get solution mu of x. So now if this bracketed function mu y minus, we know mu y not my not equal to nx, because the equation is not exact. So my minus nx, there may be some difference, non-zero difference. My minus nx by n is a function of x alone. We know m is a function of x and y, n is a function of x and y, and we take the derivative of m with respect to y and n with respect to x, and take the difference and divide it by n. Then the resulting function, if the resulting function is a function of x alone, then function of x മാത്രമാവുകയാണെങ്കിൽ എന്താ സംഭവിക്കുക? If this is a function of x alone, then we know there is an integrating factor. Then x alone ആയിട്ട് മാറി, suppose this is equal to some g of x ആണെന്ന് കരുതുക, then equation 3 will be renamed as or rewritten as d mu by dx is equal to mu into some function of x. Now mu is again a function of x alone, that we know. So mu we can take here, and we know now this is a first order differential equation, and you know how to solve this first order equation. This is a separable equation, and also it is what, linear, in the linear form also. So we can take any method. So this may have a solution. Always it has a solution. Mu has an integrating factor which also depends on x. So there exists, we can say that there exists an integrating factor mu which depends only on x, depends on x alone, and this can be solved, and this can be solved by equation 3. That mu can be obtained from this equation, can be solved by equation 3. So solving equation 3 we will get the mu. Now so this is the case when this difference my minus nx by n is a function of x alone. Then the PD, That is the solution, the equation number 2 may be reduced to this form. D mu by mu x is equal to mu into that function. So which can be solved very easily, which is a first order linear differential equation which is separable to. So any of the appropriate method we can solve it and find mu. Then again we can solve the given equation by the method of exact solving the exact solution. Now a similar process can be followed if mu is a function of if one has an integrating factor, if equation 1 has an integrating factor which depends upon y alone, which depends on isn't it? ഇപ്പോൾ നമ്മൾ മ്യൂ എന്നുള്ള ഫംഗ്ഷൻ വൈനെ മാത്രമാണ് ഡിപ്പെൻഡ് ചെയ്യുന്നതെങ്കിൽ ദെൻ ഇതേപോലെ തന്നെ ഇതേ രീതിയിൽ തന്നെ നമുക്കത് കാൽക്കുലേറ്റ് ചെയ്യാവുന്നതാണ്. കാരണം റീസൺ ഈസ് we know mu m with respect to y is same as mu n with respect to x. So then in this case mu with respect to x is 0 since mu is a function of y alone. So we can rewrite this as equation, the right side of the equation can be changed as mu into nx. So mu y into capital M is equal to mu nx minus mu my, or we can rewrite it as, how can we write this, or we can write it as mu y is equal to mu into my minus nx by minus m, isn't it? അപ്പോൾ ഈ രീതിയിൽ നമുക്ക് എം വൈ മൈനസ് എൻ എക്സ് ബൈ നേരത്തെ എന്തായിരുന്നു എം വൈ മൈനസ് എൻ എക്സ് ബൈ എൻ ആയിരുന്നു. ഇഫ് we rewrite this as equation, or we can rewrite it as d mu by dy is equal to mu into my minus nx by minus m. So if this function is also a function of y alone, then we can again solve. Again, if this is again a function of y alone, we will obtain we can solve this equation. The equation for solving for, we can find mu. If my minus nx by minus m is equal to some function of y alone, is equal to some h of y. Okay. Now let's discuss some problems regarding this. Okay, we can solve the equation which was not exact, that we discussed in the last lecture. The equation, the question was solve 3xy plus y square plus x square plus xy into y dash equal to 0, or okay, or we can rewrite this equation as 3xy plus y square into dx plus x square plus xy into dy equal to 0. Let this be equation number 1. Here m of xy, this we have already calculated. 3xy plus y square and n of xy is x square plus xy. So to check whether it is exact or not, find my. My is 3x plus 2y and nx is what? 2x plus y. So my, we know from these calculations we know that my not equal to nx. So equation is not exact. But we calculate the difference my minus nx. Now what is my minus nx? My minus nx is my 3x plus 2y minus 2x. So that is 3x minus 2x, that is x. Now 2y minus y, that is y. Now my minus nx by n, which is equal to x plus y by x square plus xy. X square plus xy, in that equation x is common factor, so x into x plus y. Um, so cancelling x plus y, we will obtain my minus nx by n as 1 by x. That means is a function of x alone. So this is the special case. The first of the special case we have already discussed is a function of x alone. So when this is a function of x alone, we know that there is an integrating factor which is also a function of x alone. That is equation 3. Then equation 3 becomes of the note becomes d mu by dx is equal to mu into this one my minus nx by n. That is d mu by dx is equal to mu into 1 by x. Now this is which is a separable equation. So separating the variables, what we obtain is d mu by mu equal to, we can write it as 1 by x into dx. So integrating on both sides, we get log mu is equal to log x plus we can write the integrating constant as log c. Okay. So we can write mu as cx. And since that means we in the theory itself we have seen that we can say that mu can be any of these values. C is an arbitrary constant, or C is an arbitrary constant. So we need only one integrating factor, arbitrary constant. So let us take mu equal to the simple function, that is x. So mu is equal to x is x will hold. So multiplying mu with equation number 1, we will get the resulting equation should be exact. So multiplying this, we get it as 3 multiplying with x. So 3x square y plus xy square dx plus x cube plus x square y dy equal to 0. So here m dash is equal to, what is m dash? M dash is 3x square y plus xy square and n dash is x cube plus x square y. Now we have to check whether this equation is exact or not. Now m dash with respect to y is equal to 3x square plus 2xy and n dash with respect to x is also 3x square plus 2x into y. So both are same. This implies m dash y equal to n dash with respect to x. Therefore, the equation is exact. Now its solution, we know how to solve in the shortcut. method we have already discussed the solution of the exact equation. If the equation is exact, the solution will be of the form. Solution is integral of m of xy dx plus integral of terms not containing x. Integral of terms not containing x. So in this in the n dash the terms are x cube and x square y. So both the terms contains x. So there is no other term containing y. So it is 0. Terms not containing x is 0. So 0 dy, or it is no need to write this term, this one, equal to, so integral m of xy dy is equal to c. We will obtain this one. So integral of integrating m dash 3x square y plus x y square. So x y square dx equal to c, or integrating, we have to integrate this with respect to x. So taking y as constant, 3y into x cube by 3 plus y square into x square by 2 equal to c, or therefore the solution is x cube y plus half x square y square equal to c. So this is the solution required solution of the equation. Okay, so let's stop here. Thank you all.